Alright, so Daryl went for a walk in the park in the morning and noticed that there were water droplets that had formed on the leaves of some plants. He touched the leaves and realized that they felt cool. So explain clearly how the water droplets had formed on the leaves of the plant. This is such a common question. If I were you, I will write somewhere, in your paper, say very, oops, sorry, put, I would like you to put very common question. Okay, very common question, so common. Some of the question use the same format. They use instead of leaves, they use on a car or on a window. But they always find some droplets of water on a cool substance early in the morning. Again, we all know that these water droplets early in the morning is what we call dew. Right, DEW, dew. Right, you can use this in your composition even. Okay, so Daryl went for a walk in the park in the morning, early morning. Okay, so there were dew. Now, how did this dew get there? Okay, explain clearly how the water droplets had formed on the leaves of the plant. Okay, such a common question, like I said. So it's very easy. At night, the water vapor, which is invisible, you can't see water vapor. Can you please remember that? You can't see water vapor. Water in its gaseous state. Okay, you can't see it, alright, because it's invisible. Okay, where is this water vapor? Is in the surrounding air. Alright, so the water vapor in the surrounding air, alright, the air that is surrounding the leaves, the air that is surrounding the car or the windows or whatever there is, at night. Okay, so it touches, alright, it touches the colder surface, right, of the leaf. Okay, uh, so you can see that the water vapor, you can also, there is the warmer water vapor in the surrounding air touches the colder surface of the leaf, right? And loses heat, right? Loses heat to the leaf lah, right? Loses heat. So the warmer water vapor in the surrounding air touches the colder surface of the leaf and loses heat. So the warmer water vapor loses heat, right? And when we know that when water vapor loses heat, it condenses, right? And loses heat, right? And condenses, right? And condenses on it, right? And condenses. You can also break the sentences up. So the water vapor, right? So the water vapor condenses condenses on it, right? Condenses on the leaf into many very or to form condenses to form, right, water droplets, right, on the leaf, and that is how it is formed. So again, because this question is about explain, right, so what is the claim? Okay, so let's see what is the claim. The claim is therefore water droplets had formed on the leaves of the plant. This is the claim. So because the claim is in the question, there is no need to write in the answer, right? So what is the evidence? The evidence we know, or scientific fact, right? The warm water vapor in the surrounding air touches the colder surface of the leaf, right? Okay, so this is one of the first evidence. Alright, and then the second evidence is loses heat, right? Sorry. Second evidence is loses heat. Okay, and loses heat. So this is the second evidence. Alright, so you can see, and then the reason lah. So what? So if it loses heat, so what? So the reason is water vapor condenses to form water droplets. Okay. So where is the compare then? You have the claim, you have the evidence, you have the reason. Where's the compare? The compare is really the word warmer. Alright. Oh, I'm gonna use a clearer color. Maybe this color. Okay. This is the what do you call that? The compare. Right. Warmer water vapor touches the colder surface. Right. So you can see that in the answer there is CCER, and that will give you full marks. Okay, so next one. At noon, Daryl observed that the water droplets on the leaves had disappeared. What could be the reason? So again, right? What is the reason for this? So what do you think the reason is? Okay, you can uh, think about it and answer it in your own mind before I type it out. Okay, so very easy, right? So the water droplets, when the, oh sorry, color is not so clear, so I'm going to change it to blue. When the temperature increases, right, or you can also say the water droplets absorb, right, absorbs, absorbs the heat, okay, or gains the heat, okay, from the surrounding, right? And we know that when water droplets gain heat from the surrounding, it what evaporates, right? Evaporates and evaporates uh, evaporates to form water vapor, right? Water vapor, right? So what? So what if it forms water vapor, right? This water vapor will uh, be will get back or go back into the this water vapor is invisible, right? Is invisible, right? And Daryl will not be able to see it, lah, right? Invisible, and therefore invisible. This water vapor goes back to the surrounding air, goes back right to the surrounding air, right, and invisible, and therefore will not be able to see. Okay, right. So again, this is the reason, lah, right? So the evidence again, the evidence is what's the evidence? The evidence is here, right? Uh, water droplets on the leaves with this. Sorry, not evidence. The claim. So this is the claim. So because the claim is in the question, you do not have to write the claim in the answer. Okay. So what is the evidence? The evidence is this: the water droplet gain heat from the surrounding and evaporates to form water vapor. This is the evidence. So what? Right. So if it gains heat from the surrounding, what's your reason then? What's the reason for you to use this? Right. So the reason is you have to say that this water vapor goes back to the surrounding air, right, and is invisible, right, and therefore the arrow will not be able to see it. So the water vapor goes back to the surrounding air, is invisible. I forgot a comma there. Right, I'm gonna see whether I can put a comma there. Right, so oh sorry. So try to put a comma there. Okay, the surrounding air. Okay, is invisible, and therefore the arrow will not be able to see it. Right, so it disappears. Right. So explain why water droplets are found only on the leaves that are close up. When Daryl opened up the close up leaves, he noticed that there were water droplets still on them, but not on the leaves that were spread out. So the water droplets on the open up leaves have disappeared, but not the water within the close up leaves. Alright, so what's the reason? Okay, so as we know, when things open up, the surface area gets bigger. When it's closed, the surface area is smaller. Alright, so you can say that water droplets on the closed leaf, right, has a lesser uh, surface area, right, lesser exposed, it's not exposed, it's close up, exposed surface area, right, and lesser surface area. So to stop, right, we know that the lesser the smaller the surface area, the exposed surface area, the lower the rate, or the slower, right, the rate of evaporation, right? Okay, and therefore evaporation is reduced now, right? So water droplets on the closed leaf has lesser exposed surface area compared to the one that is open up, right? Compared to the okay. Surface area, the smaller the exposed surface area, the slower the rate of evaporation. Okay. So what is the claim? The claim is this one. Right. The claim is water droplets were found only on the leaves that are closed up. That's the claim. So you don't have to write the claim again. Alright, and then what's the evidence? The evidence is this water. This is the evidence actually. The smaller the exposed surface area is, or the lesser, or the slower the rate of evaporation. So what's the reason for you to write this? Because because uh, the reason why we put that evidence because we want like to explain that water droplets on the closed leaf has lesser exposed surface area. Okay. Alright, so that's the reason why that's the answers for this question. Okay, so it's very easy. Alright, so I'm gonna end the question here now so that the video does not get too long. Okay, so if you don't understand, you might want to uh, explain what do you call that, replay this. If you do understand, please leave your comments in the comment section so that I know that you have watched this video, and you might want to write what you've learned from watching this very short video. Okay, so thank you very much.